So as I said, we're just gonna go over how to draw the triangles and how to label the triangles for page number 4 of your homework, and then this way you can solve the triangles. So that's page 4 of your homework. We're gonna start with question number 6. So a monument casts a shadow 13 meters long. The sun's ray form an angle of 63 degrees with the ground. Calculate the height of the monument to 1 decimal place. So what do I have? I have a right triangle, right? What's the first thing that you want to draw? Where's your monument?
Yeah, on which side you are.
Right? The monument is the first thing that you're going to draw. Right? So this is your... Now, when the monument is casting a shadow, where would the shadow be? Where do you usually see the shadow? On the ground. Right? So the monument is and this is your shadow. The shadow is on the ground. Right? Now, it says that the sun rays form an angle of 63 degrees with the ground. That's the bottom right angle, right? Right? Because that's with the ground. That's the only angle that I have with the ground. The other one is the monument, and the monument is 90 degrees with the ground because the monument is standing straight up. It's not leaning. Okay? Now we know that the shadow is 13 meters long. What am I solving for?
How tall is the building?
So I'm solving for this, right? Okay, I'm gonna leave the solution for you guys to do at home. Okay? Now, question number 6. A ladder leans against a wall, forming a 25-degree angle with the wall. If the ladder reaches 2.8 meters up the wall, how long is the ladder? So, I have a wall. Yeah? Where would the ladder be? This would be your ladder? Good. What's this?
Distance between wall and ladder.
So what's this?
Floor.
The
On
ground. Right? Because the wall is leaning on the ground. The ladder is leaning on the ground and on the wall. Right? So this is your wall.
Which is 2.8.
This is your ladder. And this is the ground. Right? Now the ladder makes an angle of 25 degrees with the wall. Which one would be the 25 degrees? Top angle. Ladder, wall. The ladder reaches 2.8 meters up the wall. So what's the 2.8?
Last time.
The wall. And what am I solving for?
The size of the ladder.
So I'm solving for this, right? Height. That's a 2.8, not 2-8. Just read the question, if not the first time, the second time, and try to imagine what you have. What are the components that makes up your question? Okay? So the first thing I asked you, what is the question made of? It's made up of a wall, a ladder, and the ground, because the wall is leaning on the ground and the ladder is leaning on the ground, right? Think about what the question is telling you.
What's the
Sorry?
What is the 2 for the letter?
Question mark.
That's a question
Oh,
mark.
question. That's
Yeah,
2.
because I need to solve for this.
Okay.
Eight. Jasmine is planning to climb up a cliff face. She still be attached to a rope anchored to the top of the cliff. To find out how much rope she will need, she uses a clinometer to check the height of the cliff. She stands 500 meters from the base of the cliff and measures 73 degrees angle to the top. How high is the cliff? So what's my components here? There's a lot of like fillers in here, right? Like the first 2 sentences, I don't need, right? So if I want to read again, I would read the next part.
Find out.
To find out how much rope she will need, she uses a clinometer to check the height of the cliff. She stands 500 meters from the base of the cliff and measures 73-degree angle to the top. So what's the first thing that I want to draw?
The ground.
Sorry?
The cliff.
The cliff.
Okay.
So let's say this is my cliff. Right? Now, where is Jasmine standing?
500
From the base of the cliff. So Jasmine would be standing right here, maybe? Right? And the length of this is 500 meters, right? Now, she measures an angle of 73 degrees to the top of the cliff. So where would her angle of 73 be?
Where she stands.
Where she's standing to the top, right? So it will be right here. Now the question is asking you how high is the cliff. So I'm trying to find this, right? Again, this is what I will try. Okay, draw the next one. Okay, try to draw it. I'm gonna draw it here, and let's see if we can, if we'll have the same answer. I want to vote of who has exactly the same drawing as me. Yes?
Yes.
Try to graph it without looking at the picture. Yes?
Which is the angle of the we need to find the. So in this question, we're looking for the angle.
Homework. Yeah. this is what
Oh
you're
man,
looking for.
I just switched to the side. I gotta reverse it.
then that's wrong.
Yeah, well, I know.
You have to be careful because the ladder is 4 and the ladder is bigger
Yeah.
than the wall
Yeah.
because it's a hypotenuse. You guys want to solve this or you're okay? You know how to solve this? You'll be able to solve it? Okay, let's draw the last picture.
What? Maybe we need to solve it with you, teacher.
Yeah?
Yeah,
You know.
can we do that together?
Okay. So, where's my angle of focus? What's the question I asked you to do?
Find the angle.
Find the angle that we form with the ladder with the wall, right?
Yeah.
So that is my angle of focus. This right here
Yeah.
is my angle of focus. Okay? Now, what is this? Name the triangle for me with respect to the angle of focus. So the ladder is what? Hypotenuse. This is what?
Adjacent?
Opposite?
No, opposite.
Oh. Yeah.
The wall is?
Adjacent.
So, what are the, since I don't know the angle, right? I'm looking for the angle. What are the 2 sides that I know?
Adjacent and
So which one I'm going to use? Right? Okay, do that on the calculator. What's 3.4 divided by 3.5 divided by
0.875?
anything after that?
No.
Okay. I'm looking for an angle. What do I have to do?
The second function
Inverse.
and inverse.
Inverse. Good. So A is cos inverse of 0.875, which is
Correct.
29 degrees. Therefore, the angle that the ladder forms with the wall is 29 degrees. Anytime you're dealing with a word problem, you must put that therefore statement. Are we good with that? Please tell me that you're not having problems with
No, we don't mind.
this. Okay.
We just need one angle in this question.
Yeah, that's all the question's asking you. You're done. Little more confusing, if you want to say. So, let's see. So a rocket is launched at an angle of 80 degrees to the ground and travels in a straight line. What is the rocket's altitude when it has traveled for 15 kilometers? So, what's an altitude? A height. So when you're talking about an altitude, you're talking about height that's 90 degrees to the horizontal. Okay? So let's say this is your rocket. Right? And it has been launched at an angle of 80 degrees. Right? So if 80 degrees to the ground, right? So that means this is your ground, and then something that looks like this, right? So this is the ground, and the rocket is 80 degrees.
Shouldn't it be 80 degrees from the ground?
It should be from the ground.
Because 2 makes it sound like it's going
Yeah,
down.
it is.
Being launched
It is from the
back.
ground. It doesn't make any sense that it's 2.
Oh.
Okay, now the question is, after that rocket has traveled for, what's the question again?
15 kilometers.
Have traveled 15 kilometers. What is the altitude? So 15 kilometers is, I think I made a mistake on your stuff. It traveled for 15 kilometers, right? Because remember, this is the path of the rocket, right? So what is the altitude? What is the altitude of the rocket? So how high is the rocket above the ground? Okay, so the rocket started here. It flew for 15 kilometers. Now they want to know what's the altitude of that rocket. Are we okay with this?
So we have to find only one thing, right?
That's correct. You have to find the
The
opposite,
opposite side.
knowing
Opposite side.
hypotenuse.
Okay, so we're looking for sine.
Yeah.
Sine. So.
Okay? Alright. Moving on to cosine law, because I need to finish cosine law and some word problems by the end of the day.
This is Mr. Jennings.
Say, where are you?